We're asked to find the derivative of y with respect to x involving trigonometry now. So the textbook goes over some of these definitions, but the derivative with respect to x of sine of x is just cosine of x. And so here I've got the graph of sine of x, and I've got the graph of cosine of x. So this isn't a proof, right? This is just the intuition here. Look, the slope right here looks to be close to 1, right, of sine of x. That's why the derivative of sine of x is cosine of x, because remember, if this is the graph of the derivative, then the y-axis are slopes. At x equals 0, y equals 1 on the graph of cosine of x, right? And then over here, the slope is 0, and that's why on the x-axis it crosses the same place for cosine of x, 0. It's 0 for y because these are the slopes. So this is the graph of sine of x, and this is the graph of the derivative of sine of x, which happens to exactly match cosine of x. Okay, so in other words, the derivative of sine is cosine. Okay, and if you go in reverse though, careful. First semester calc students often think the derivative of cosine must be sine then, but it's not. It's negative sine of x. Okay, and I think that's problems later on in the problem set to prove that. A couple others. The derivative of tangent x is secant squared x. Let's see what else we need. I think there's, I don't know if I'm giving it away, but these next ones, the derivative of cosecant x, sorry, that's just finding the derivative of 1 over sine of x, right? Because sine of x is the reciprocal of cosecant of x. In other words, cosecant of x is the same thing as 1 over sine of x. And if you use the quotient rule, it's the derivative of the first function times the second function kept the same, times the first function kept the same, times the derivative of the second function over the first function squared. Okay, so this is the derivative using the quotient rule. And that simplifies to be sine of x over sine, sorry, whoops, this is supposed to be cosine. Cosine of x over sine squared x, which is the same thing as cotangent x times cosecant x. Okay, and if you're not sure how I got that, that's okay. That's something that we can practice later, but that's something that's usually done in pre-calc. So the derivative of cosecant of x, I just showed using this and this definition that it's equal to cotangent of x cosecant of x. And a few more. The derivative of secant x. This one's kind of weird. It's, sorry, whoops, I jumped ahead. Derivative of secant x is, I just realized I was writing really messy, so here they are. The derivative of secant x is kind of weird. It's itself times tangent of x. And the derivative of cotangent of x, the last one we didn't get to, it's CSC x squared. So here, derivative of cotangent x, I guess the one I picked is a little weird. Derivative of cotangent x is cosecant, negative cosecant squared x. But you could derive them just like I just did in that last one. Okay, I think I've got everything there now. That's also in our textbook too, so you can probably turn back to those. But okay, so we need those for finding these derivatives. The derivative of y with respect to x, can symbolize that with shorthand, y prime. You can do it term by term, right? That's the cool thing about differentiation. It's like it distributes, even though it's not technically a distribute property. So the derivative of 2 sine of x is just 2 cosine of x, because the derivative of sine of x is cosine of x. And remember, this isn't the derivative of a constant. This constant is multiplying to something, so that's why the 2 sticks around. It doesn't turn to 0. If that was the derivative of 2 plus sine of x, then the 2 would disappear. But this is 2 times a function of x, so the 2 hangs around. And the derivative of tangent of x we just saw is secant squared x. And that's it. That's our derivative of y with respect to x. Maybe you could rearrange a little bit, but I think that's fine right there. Let's do this next one, because this one is probably easier, and the next ones will just keep ramping up the difficulty. Look, 2 distinct functions of x multiplying to each other, so that means we need the product rule. So it's the derivative of the first function with the second function kept the same. plus the first function kept the same times the derivative of the second function. And if you go back in your book, or if you go back to when we derived, oops, sorry, I took it out. But remember, the derivative of secant x is secant x tangent x. It's a weird derivative. So the derivative of the second function is itself times tangent x. I don't think we can clean that up anymore. You could factor out a secant x, I guess, but that won't really make anything cancel out or simplify. So that's it. That's the derivative of y with respect to x for that one. This next one is set up for the quotient rule, right? The quotient rule says that it's the derivative of the top function with the bottom function kept the same. So the derivative of the top function is 1. The bottom function is 1 plus cosine of x. Subtracted by the top function kept the same times the derivative of the bottom function. The derivative of 1 plus cosine of x is negative sine of x, because the derivative of 1 is 0, because that's a constant all by itself, and the derivative of cosine is negative sine of x. And then if you keep following the quotient rule formula, it's the entire bottom squared. Okay, so we can clean that up a little bit. This is 1 distributing to everything, so this is just 1 plus cosine of x minus, this is now going to be plus because it's minus a negative, and that's x sine of x in the numerator. And that's all over 1 plus cosine of x squared. That's it. So we've used the quotient rule. And then same thing for this one. Two functions of x being divided, so we can use the quotient rule to find the derivative. Okay, so the derivative of cosine is negative sine, so it's the derivative of the top function times the bottom function kept the same, subtracted by the top function kept the same times the derivative of the bottom function. The derivative of this function down here with respect to x is cosine of x. And that's all over the bottom function squared. Okay, I have a feeling we can clean this up a little bit. There will be something that'll cancel out, so let's see. So in the numerator, if I distribute that, that's negative sine of x, and the negative sine times positive sine makes negative sine squared. Oops, so that should be negative sine squared in the numerator. Okay, I'm just distributing. And then over here, that's cosine times cosine, so that makes cosine squared x. Oh, I see. Okay, so when you're dealing with trigonometry, you always want to be looking out for trig functions that are being squared, because we can use something called the Pythagorean identity. Okay, there's a fact that sine squared x plus cosine squared x, that always equals 1. Okay, and we've got that here. You just need to factor out a negative. Okay, so if you factor out a negative from both those terms, so this is negative sine of x plus sine squared x plus, plus a negative sine squared x plus cosine squared x all over 1 plus, oh man, my hand is killing me after this one. Okay, I factored out a negative 1 from both of these, because then I've got sine squared plus cosine squared, which is 1, right? So this entire parentheses is just 1. So if you finish, too much yucky stuff down here. The eraser tool is no good on this program. Okay, so if we finish that out, that's negative sine of x minus 1 over all that stuff in the denominator. Use quotes to just repeat it, okay? So that's it. That's the fully simplified version. So be on the lookout for that. For sine squared plus cosine squared. That should equal 1.